today we're going to discuss about explicit formula. This is a formula that allows us to find the end term of a sequence. Unlike the recursive formula, explicit formula allows us to go straight to the end term of any sequence. Explicit arithmetic sequence is the first one that we're going to discuss, and our example is 35, 32, 29, and 26. Let us review a little bit about arithmetic sequence. It is a sequence where you have to add or subtract the same number to your sequence to go to the next. So for this one, just to organize everything, I'm going to divide this into rows, and I'm going to call this my AN, and I'm going to call this my N, and I'm going to write here the common difference D. So once again, this D is our common difference. Okay. So from 35 to 32, my D is a minus 3. From 32 to go to 29, I am subtracting 3 again. And from 29 to 26, I needed to subtract 3 again. The N is the position of each of your sequence. So this is position number 1, position number 2, position number 3, position number 4. Therefore, this is A1. This is right here is A sub 2. Sorry for that tiny notes right there. A3, and this is our A4. Going all the way to AN, and this is again our D, and this is our N right there. So how are we going to, let's look at this. So let us have the equation. So what you need is for you to get your A sub N, by the way, can be N from positive 1 all the way to infinity, because really your sequence can go all the way to infinity. And now we can go ahead and we need our first term. And for us to go from 35 to 32, we are subtracting a 3. From 32 to 29, we are subtracting another 3. Notice that what we are doing here is as we go, we are really adding the common difference. In this case, subtracting, I will just put, you're adding the common difference of D. But guys, please remember, if I'm looking at my second position right here, how many D's have I added? I only added one single D. On my third position, from the first one, I added how many D's? 2 of the D's. If I'm looking for the fourth term, how many D's technically have I added? 3. Therefore, the D and the position have a relationship, and that is, for you to get to the end term, you will have to get the first term, add D, but make sure that D is multiplied by N minus 1, because you are adding 1 less than the position. For better understanding, let us have an example. Using the same sequence, let us pretend that, let's look for the fifth term, which we all know here should come out as 23. So let's follow the formula though. I am looking for the fourth term. I'm looking for the fifth term. And according to the formula, I need my first term. I need to add my common difference of negative 3. And my N is 5. And it's always less than 1. Let's rewrite this. So A sub 5 equals 35 plus negative 3 times 4 and plus negative, oh well, we can do this first. So a to the fifth, a sub 5 equals 35 plus negative 12 plus negative is the same as minus. So a sub 5 is 23, which is our expected answer. Let's have another example. What if I'm looking for ace of, okay, let's divide that. So a sub 7. So a sub 7 should be needing a sub 1 still, plus d times n minus 1. So let's rewrite. A sub 7 should be equal to 35 plus negative 3. Your n is 7, so this should be 7 minus 1, and that should be inside the 6. So this is going to be 35 plus negative 3 times a 6. A sub 7 is equal to 35 plus negative 18, and a sub 7 should be 17. I want to challenge you and go ahead and extend your sequence right here. Extend this sequence and make sure you look for the 7th term and see if that is going to be a positive 17. Okay, so once again, in doing this arithmetic sequence, you need the following components. If you're looking for a sub n, you make sure that you have the following given. Make sure that you have a1, which is the first term. Make sure you have your d, which is your common difference. And make sure you are able to convert your n minus 1. And plug all of this in the formula. So now let's have explicit geometric sequence. Geometric sequence is the type of sequence where you have a common ratio. So you are either dividing or multiplying to go to the next term. So let us look at this. 8 divided by 4 is a2. 16 divided by 8 is a2. 32 divided by 16 is a2. So once again, this right here is your an. This right here is what we call your r. And this right here is your position 1, position 2, 3, and then 4. So let us look at this. For us to go to A2, let's examine this first before we generate the formula. So before you go to A2, what you need is the A1. And you're going to multiply it by your R, which in this case is 2. But I'm just going to use R because we're trying to generate our equation, okay? So now, when you go to 3, A3 needed, again, A sub 1, which is your first term. But please notice that this time, you are multiplying R and R. When you go to A4, what you're doing is A1 times R times R times R. So let's look at this. Notice that your position and your R are related. If you're in position 2, there is 1 R you're multiplying. If you're in position 3, there are 2 R's you're multiplying. If you're in position 4, there are 3 R's you're multiplying. So again, we're looking at something less than 1 here. Now, please be careful because this is multiplying already by itself. So this is power. Therefore, A sub n is equal to the first term times the common ratio raised to the power that is the position less than 1. So whatever position is, which is n, must be less than 1. And that is, we derive that based off of this proof. So to better understand this, let us have an example. Let us look for a sub 5. And looking at this, if I multiply 32 by 2, I know that next to my sequence is going to become a 64. So we're expecting an answer that is a 64. So let's look at the formula and apply the formula. So first of all, my A1, let's get all our information here. My A1 is 4. My common ratio is a 2. And the n that I'm looking for is a 5. Okay, using all this information, I'm going to plug in the formula. My A1 is 4 times my R is a 2. Power of, and I'm looking, my n is 5, so 5 minus 1. And then I'm simplifying. So my A5 is going to be 4 times 2 to the power of 4. 2 to the power of 4 is not 8. Please be careful on this one. Here, let's do it. 2 to the power of 4 means 2 times 2 times 2 times 2. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. Therefore, this whole thing is 16. So we are going to have 4 times 16, and I believe 4 times 16 is 64. So that is our A5. Oh yeah, it matches. Because if you extend this, it's going to be 64. So we will have another example, and I want this other example to be look for ace of 8. So let's challenge ourselves. Look for ace of 8. So once again, let's plug in the same information. So we have our first term to be a 4, our common ratio to be a 2, our power to be, in this case, 8 minus 1, because that's your in right there. So let's have this 4 times 2 to the power of 7. 2 to the power of 7 is not 14, because that means 2 times 2 times 2 times 2 times 2 times 2 times 2. Make sure you have 7 of those. 1, 2, 3, 4, 5, 6, 7. And this, I believe, is 128. So now we are going to have a sub 8. That's a sub 8 equals 4 times 128, which I believe is 512. My challenge to you is go back to your sequence, extend this up to the 8th term by consistently multiplying 2, and see if you're going to have 512.